Hello students, welcome to the video on the rectifiers. So here we will be discussing about what is rectifier, what are the parameters to be chosen for a diode to be a good rectifier. So in the previous videos we have discussed about what is meant by PN junction diode, what is meant by reverse bias and what are the breakdown mechanism. So here first to understand the concept of rectifiers, first we will see what is meant by piecewise linear approximation. So any diode can be approximated to an equivalent. So first case I assume that my diode is an ideal diode. So ideal diode VI characteristics will be zero conduction in negative side, and also the current will be maximum at when it is forward biased. So the first graph represents the characteristics of an ideal diode. In the second case, we assume that any diode will be having in series an voltage that is E naught, the potential voltage. So now the diode can be approximated as an ideal diode with an offset voltage E naught. The third case is we have an ideal diode with an offset voltage and a resistance to account for slope in the forward characteristics. So these are the three approximations we have for a diode. Now coming to a rectifier. So we know that rectifier is a circuit which converts an alternating current to an unidirectional current. That is, rectifier is a circuit which will conduct for one half of the cycle and which should not conduct for the other half of the cycle. So when I choose a diode to use it as a rectifier, what are the characteristics the diode should possess? The first thing is the diode should be close to ideal characteristics as possible. So what is the ideal characteristics? That is, it should conduct during the forward bias and it should not conduct during the reverse bias. So the next condition is the reverse saturation current. That is, it should not conduct in the reverse bias means that the reverse saturation current should be zero or it should be negligible. The third one is the forward current should have zero resistance or it should have a very low resistance. The offset voltage Vf should be small. So these are the conditions for an ideal diode. Now, to choose an ideal diode, a very important parameter to be chosen is the band gap. So, band gap is of prime importance in choosing a material for the diode. That is, a band gap is a gap between the valence band and the conduction band. The intrinsic carrier concentration is nothing but the carriers which is generated thermally. So, when band gap is large, the carriers which are generated will not have enough energy to pass from the valence band to the conduction band. So when band gap is large, so my reverse current will be very low. Or also with a larger band gap, the device can work with higher temperatures as thermal generations of the HP is reduced. So for a diode, if I choose a larger band gap, two things happens. One is less number of thermal carriers are generated, and also the movement of thermal carriers will also be reduced. But what happens to the potential barrier? So a larger band gap increases the forward voltage also, but this however is outweighed by the low intrinsic concentration. Also, silicon diode is preferred over the germanium for all the rectifier circuits of high power because of its wider band gap, lower leakage current, higher breakdown voltage, and it is easier to fabricate. Next, if in a junction, if one side is heavily doped and the other is lightly doped, we know that the lightly doped junction part will decides the property of the junction. So the lightly doped region will decide the resistivity of the region. So it will be having a very high resistance. So a high resistivity region should be at least used in one side because it will increase the breakdown voltage. But this increase in the breakdown region because of this lightly doped region may increase the forward resistance. So it may reduce increases the heat which is produced when the diode conducts. So to reduce the heat, we know that the resistivity is given by R is equal to resistance is equal to rho into L by A. So to reduce the resistance, I have to either make the area of cross section more, or I have to reduce my length of the device. But area of increasing the area may result in difficulty of uniform fabrications, and localized flaws may cause breakdown, and length cannot be also too short. So when the length becomes too short, so the punch through happens. The next case. What is meant by punch through? When we have a short lightly doped region, the transition with the W increases with increase in reverse bias, and that may extend to the lightly doped region. So it may touch the edge of this region which is slightly doped. So this results in the punch through. So here to avoid this we use a guard ring. The effect can be reduced by beveling the edge or by diffusing a guard ring to isolate the junction from the edge of the sample. The electric field is lower at the beveled edge of the sample than it is at the main body of the device. That is, I try to dope the lightly doped region near the edges with a highly doped region. So this may reduce my punch through effect. So here in this diagram we can see that N is the lightly doped region. So to the at the edges I can go for a heavily doped region N plus. So this together will give me an N region of the N region which will be used as for the rectifier. So P plus is a heavily doped region which is P region, and N plus together they will be called as an N region. So it is normally used to terminate the lightly doped region which is a heavily doped region of the same type to avoid the punch through. So the mounting of the rectifier junction is also critical, and its ability to handle the power. Normally, a typical silicon power rectifier is mounted on a molybdenum or tungsten disk to match the thermal expansion property of the silicon. So the disk can be fastened to a large stud of copper or other thermally conductive material that can be bolted to a heatsink with appropriate cooling. So this completes the video on rectifiers. So we have discussed what is meant by a rectifier, what are the components, devices, for characteristics to be chosen for a good rectifier, what is meant by guarding, and also how to dissipate the heat which is generated in the power rectifiers. Thank you.